geologist, volcanologist, seismologist, paleontologist, oceanographer, meteorologist, cartographer, astronomer.
The scientific method goes like this. 1. You make an observation.
2. You create a question about what you observed.
3. You develop a hypothesis consistent with your observation.
4. Use the hypothesis to make a prediction.
5. Test that prediction with experiments or further observations.
6. Analyze the results of the experiments or observations.
7. Make a decision to accept or reject the hypothesis.
8. If necessary, go back to step 3, create a new hypothesis, and repeat.
And 9. After testing thoroughly, formulate a theory. Oops, I did it again. This is the second time this week I knocked my toast on the floor. My name is Khalid. I'm not a scientist, but I sometimes sort of think like one. That's what I learned in science class. You see, when scientists investigate things that they're curious about, they use a step-by-step approach called the scientific method. It gets them reliable answers. Without realizing it, I sort of explore stuff that I'm curious about in a similar way. Take my curiosity about jelly toast sliding off the counter and landing on the floor. It seems to always land jelly side down. I wonder if that always happens. Let's find out by starting with the question. Does toast sliding off the kitchen counter usually land jelly side down? Hypothesis. The toast usually lands jelly side down. So my prediction is, if I slide the toast off the counter, then would it land jelly side down? To test the prediction, I will slowly push 10 separate slices of jelly toast with equal amounts of jelly past the edge of a 36-inch high platform and count how they land. Analyzing the results, 9 out of 10 drops from a 36-inch high platform land jelly side down. This leads to my decision that from a 36-inch high platform, the toast will land jelly side down about 90% of the time. The hypothesis holds. I wonder what I could change to get the toast to land jelly side up. If the platform were higher, what would happen? This means changing one of the controls like the height into an independent variable. The question is, does sliding toast off a platform higher than 36 inches result in the toast landing jelly side down? So the hypothesis becomes, regardless of the height from which the toast falls, it usually lands jelly side down. If I slide the toast off a higher platform, I predict it will usually land jelly side down. To test this, I will slowly push 10 separate slices of toast from platforms at different heights and count the results. Each slice will have an equal amount of jelly. Let's analyze the results. The toast landed jelly side down for 3 out of 10 drops from 44 inches. 7 landed jelly side up. I decide that from a 44-inch height, the toast usually lands jelly side up. So the hypothesis that the toast usually lands jelly side down is rejected. Here's my scientific theory of jelly toast. If toast is pushed off a platform of 36 inches, it's most likely to land jelly side down. From 44 inches, it's most likely to land jelly side up. As I push the toast off the platform, it starts to rotate. So the higher the toast is, the most likely it is to land jelly side up. I wonder what else I can experiment with.
When I'm the first one home, I always seem to have a problem finding the light. Here's what my brain does when I end up standing in the dark. This is my situation, or if I were outside looking in, my observation. I come home at night, bumble around in the dark, find the lamp, turn the switch on, and no light. and here I stand in the dark. So the first question, of course, is the power out? My hypothesis: the power is out. Let's see. I predict that if power is out, then the lights are out at all the houses in the neighborhood. I'll experiment again and test the light. I switch it off, on, and still no light. Next, check for lights around the neighborhood. Analysis. If I see light in the neighborhood, then I must reject the hypothesis that the power is out. If I see no other lights, my prediction is true, and my assumption that the power is out is true. Since I see streetlights and lights in the windows around the neighborhood, I decide to reject the hypothesis that the power is out. But I'm still in the dark. What next? The question is the light bulb burnt out? My new hypothesis: the light bulb is burnt out. If the new hypothesis is true, then I predict the light will come on when I install a new bulb. I'll get a new bulb and install it. I put in the new bulb, and it lights. Analysis. The original bulb would not light, but the new one does. I can't reject the burnt-out bulb hypothesis, but I have no proof that the old bulb is burnt out. Another prediction. If the burnt-out hypothesis is true, then the broken filament in the bulb will rattle when I shake it. To test my prediction, I shake the old bulb. No rattling. My analysis leads to the decision to reject the hypothesis that the bulb is burnt out. How confusing. I guess more testing is called for. Maybe the old bulb was loose in the socket. Another hypothesis. The bulb was loose. Let's make a new prediction. If the hypothesis is true, then the old bulb will light when I reinstall it. To test the prediction, I tighten the old bulb. Now it lights. Analysis. I can't be sure that the bulb was loose. I decide I can't reject the hypothesis of a loose bulb because past events cannot be tested. I have no proof. The evidence here supports my theory that the bulb was loose in its socket. In science, a theory is an idea that is tested thoroughly. I mean really thoroughly. In fact, it's tested so thoroughly that it cannot be rejected.
The scientific method is a thinking process based on human curiosity. We are constantly questioning our quick-to-notice patterns, correlation, cause and effect situations that happen around us.
The scientific method. It's a process that follows this step-by-step procedure. 1. Make an observation. 2. Turn it into a question. 3. Develop a hypothesis. 4. Make a prediction. 5. Develop an experiment. 6. Analyze the results. 7. Make a decision. 8. Repeat the process if necessary. And then 9. State your theory. It's a process that leads us to a better understanding of our world and ourselves.